All right, so today's lesson is on solving quadratic inequalities. And so there's a couple things we need to make sure we're doing. Step one, factor the polynomial using your favorite method. That's the first thing we wanted to do. Then we want to draw a sketch of the quadratic graph using x-intercepts and the direction the graph opens to determine where the graph is positive and negative. And then finally, the x-intercept values, are the ones that need to be used in the inequality. And we also can double check. We want to substitute in x values into the original equation to double check our answer. So let's look at 5x squared plus 12x plus 4 is less than or equal to 0. So I'm going to use factoring by grouping here. So I'm going to say 5x squared, and then I have 5 times 4 is 20. The two numbers that multiply to be 20 and add up to 12 are 10 and 2. So I'm going to put 10x plus 2x, have the plus 4, less than or equal to 0. And then I'm just doing my factoring. 5x times x plus 2 times x plus 2 is less than or equal to 0. And then I combine my GCS. 5x plus 2 times x plus 2. Those are my factors. Now, to find my x-intercepts, I need to set them both equal to 0. So I'm just going to set them equal to 0 at this point. 5x plus 2 equals 0. So that's 5x equal to negative 2, x equal to negative 2/5. And then my other one, x plus 2 equals 0. So x equals negative 2. So if I'm sketching a graph, I'm just going to put a couple points, negative 1, negative 2. I'm going to count them up, and then I'm going to graph it. So I know I cross at negative 2 and negative 2/5 in there. Looking at this 5x squared, I know opens up. Okay? And then also what I like to do is I like to check what is f of 0. So when x is 0, that's my y-intercept, so it's at 4. So I can graph this pretty easily, and I can see that's kind of the basic shape. It might not be perfect, but I know over here it's positive, in here it's negative, and out here it's positive. And so I'm asked the question, when is it the graph less than or equal to 0? So when I look at that, I would say, obviously, in this part here. So my final answer, I would use, it's all this part in here. So it's between negative 2, and it's less than or equal to x, and less than or equal to negative 2/5, because it is less than or equal to. All right, so that's our first answer, negative 2, less than or equal to x, less than or equal to negative 2/5. Let's look at our second one. We have x squared plus 4x minus 5. So we can just factor this out. 1 times negative 5 is negative 5. The two numbers that multiply to negative 5 and add up to 4 give us x plus 5 and x minus 1. It's greater than or equal to 0. So I had to find my intercepts. So I set x plus 5 equal to 0 and x minus 1 equal to 0. So I get negative 5 and 1 as my intercepts, and I'm also going to check to see what f of 0 is. So when x is 0, my value is negative 5. So now when I look at my graph, I know I'm at negative 5 and 1. I now have to go down to negative 5. So I'm going to plug in my x-intercepts, negative 5 and 1, and my y-intercept, negative 5. So I can see it goes like this. It's going to go down. So my graph, let me redraw that graph. I think I can do a better job. So it's going to be something like that, although it didn't exactly hit, but you get the idea. All right, so here I know it's positive, negative, positive. And I'm looking for when the graph is positive because it's greater than or equal to 0. So that means I'm looking for these areas here and here. So when I'm writing out my answer, I know it's positive. It starts from negative infinity and is positive all the way until I get to negative 5. So I would say x is less than or equal to negative 5. Or I also know once I hit 1, it's positive the rest of the way. Or x is greater than or equal to 1. So that would be my solution. X less than or equal to negative 5 or x greater than or equal to positive 1 because that is where my y values are positive. All right, so let's look at the next page. We've got 2 more examples we want to do. And if we look at this one, number 3, we have to use completing the square in order to factor because we can see that a times c is negative 5. There's no two numbers that multiply to negative 5 and add up to negative 8. So we have to do completing the square. And so I'm going to move my c value over. And I'm just going to use an equal sign just to make it simpler right now. And then I take my b value and I cut it in half. And then I square that value. So that 16 is what I add to both sides of the equation in order to maintain balance. So x squared minus 8x plus 16 equals 5 plus 16. Now I factor the left-hand side. And what's nice thing is that this negative 4 will be my factor. So it's going to be x minus 4, the quantity squared. That's why they call it completing the square. And then plus 21. So in order to, I have to find my zeros. So what I have to do here is then take the square root. The square root gets rid of the squared sign. So this becomes x minus 4 equals plus or minus the square root of 21. And so when I'm solving, I just take the 4 over. 4 plus or minus the square root of 21 will be my 2 intercepts. And then also, my f of 0, if you look, is negative 5. So I know 3 points. I know the direction it opens. It opens up because the x squared term is positive. So I'm just going to kind of go by 5s. There's 10, negative 10. Okay, so with the square root of 20, we have x, the intercepts are at 4 plus or minus the square root of 21. Well, we know the square root of 21 is somewhere between 4 and 5. So when we add that to 4, it's going to be between 8 and 9. So I'm just going to draw a point right around there. And then when we subtract it from 4, 4 minus around 4.5 is going to be about a half. We know it opens up, and we know it also has a y-intercept at negative 5. So it's going to look something like that, where it crosses the x-axis twice, hits the y-intercept at negative 5. We know it's opening up, and we know this is negative, positive, positive. And so it's asking us when is this graph less than 0. So we know in this part that I'm shading in, that's where it's less than 0. So we would say 4 minus the square root of 21 is less than x is less than 4 plus the square root of 21. All right, those are the 2 intercepts. So that would be my inequality for number 3. 4 minus the square root of 21, less than x, less than 4, plus the square root of 21. All right, our final one. So this one is different because it has a negative out front. So we know it's going to open down. When I factor this one, I'm going to use factoring by grouping. So I'm going to use negative x squared. The two numbers that multiply, negative 1 times 9 is negative 9. The two numbers that multiply to be negative 9 and add up to negative 8 will be negative 9 and 1. So I'm going to make it minus 9x plus 9 for my factoring. So I'm going to take out a negative x here and be left with x plus 9. I'll just take out a 1. We're left with x plus 9. So my factors are negative x plus 1 and x plus 9. I'm going to set it equal to 0 so I can find the intercepts. So when I set each of these equal to 0, I'm going to get negative x equals negative 1 or x equals 1. And over here, x plus 9 equals 0 or x equals negative 9. So those are my two intercepts. And then when I find the function when x is 0, it's just going to be positive 9. All right, so we know we have a point at 1 and negative 9. I'm just going to label those two. And then we know we have a point at 9. So when we're graphing this, we're here, we're here, we're here, and we know it opens down because the x squared is negative. So that means it's going to look something like something similar to that. All right. So now over here is negative, and in the middle is positive. So it's been flipped upside down. We're asked to find when is it less than 0. So that means it's in here and in here where it's less than 0. So that means x has to be less than negative 9 or x has to be greater than 1. One of those two things has to be true for it to fulfill the inequality. And that's solving quadratic inequalities.